And yes, we welcome. We're now to 36. This is an excellent showing. And so this is our second Passion Project Showcase. Our first one was last quarter. And there is a link, I'm going to repost it here in the chat, that goes to our webpage that Rhonda Kitchens, our co-chair for this committee, created, and she developed a beautiful ebook. So that's a gift to all of you who would like to. You can view that and listen to it online after this, so you can learn a little bit more about all the things that Jim does that are great for our students. And before I talk a little bit about Jim, I just want to say that when I first met him as the Renaissance man. And it was really cool to meet Jim kind of outside of school for me. I met him through his musical work. And he loves to play music, and he does so in the Moses Lake community particularly. And I look forward to when the pandemic can end so we can go see more of Jim's live playing. He's an excellent musician. And Dr. Jim Hamm has been teaching at Big Bend since 1993. In that time, he has primarily taught physics, astronomy, and science courses, although he has at one time or another taught almost every mathematics course from pre-algebra through differential equations. And the only math courses he has missed are statistics, first quarter calculus, and linear algebra. Before Jim came to Big Bend, he taught for a couple years part-time at Edmonds Community College and North Seattle Community, but luckily we've been able to have him for almost the last 30 years. To make ends meet during those years, he also drove for Shuttle Express and airport service, which I know I have taken advantage of, and it's very familiar to those of us who are this far on the east side of the state. And prior to that, he taught at Eastern Oregon State College for 2 years. And before that, he was in graduate school at the University of Minnesota, graduating with a PhD in physics. And since 1993, he has been here inspiring our students and being a big part of the Moses Lake community. And Jim's passions are broad and kind of inspiring, especially for me as I figure out where to find my own place as both a faculty member and a member of our community. And so I'm really thrilled to be able to introduce Jim. One thing I also want to remind you again, yes, if you have any questions at all, please share them in the chat, and Tiffany will be monitoring those. After Jim does his presentation, there's going to be a small Q&A from a group of us who are part of the Passion Project Showcase. We're each going to ask him a question that we want to know about his passion. And then after that, we're going to open it up to everyone to share their own questions or even your own insights, memories, experiences of learning with Jim, or things that make you excited about astronomy and the stars and the constellations. So thank you for attending, and with no further ado, I'm going to introduce Dr. Jim Hamm. Thank you, Jim.
You betcha. Okay, I'm gonna share my screen over here and see if we can make this thing work. You see the night sky? Maybe?
Oh, sorry, Jim, I accidentally muted you. Sorry, just a second. Let me unmute you. That was my fault. I did not mean to do that. Can you unmute yourself? I've said it. What did I do? I can't.
Did I just unmute myself?
Thank you. Yes, you can mute.
Okay. I was trying to find my directions for the PowerPoint here, and maybe I did it. Might have been better if I was muted. Who knows? Okay, as I advance through slides, I may have to use my keyboard. I'll try to use my mouse, which is quieter, but I've got a gamer's keyboard that makes loud clicks when you hit the keys, and fair warning. So I'm going to start off with a little bit of a, well, not such a little biography, because heck, I'm retirement age. I've got a long biography. So we'll be addressing that. But then I'll talk about some of the things that I really like to do, just a handful of them. I don't know, I think a good saying for me would be, he who dies with the most hobbies wins. And I'm working on that. So lots of things, but I'm just touching on a few of them here tonight. So we'll see how that goes. Okay, so about me. I'm married. I have 3 adult daughters, all of whom are on here, and 3 granddaughters. And I also have 5 siblings, 3 of whom are on here. One of them has probably gone to bed already. He lives in Wisconsin. And my brother's camped out somewhere. So other brother, anyway. I was a student in the very first kindergarten class in Warden. They hadn't even had kindergarten before that year. But I did not graduate from kindergarten. And it wasn't that I was an academic failure and scarred for life or anything. It was because my family moved to Spokane in October. So I only went for a couple of months. And the family lore is that, well, I know I took or played hooky from kindergarten. I'd start off walking to kindergarten and I'd go back home, and I didn't really know why, but my mom said one day, one of the kids said to me at kindergarten, they called me James in those days, and or maybe they called me Jimmy, I can't remember, but they said, what if your family moves while you're here? And that day I tore out of kindergarten and ran all the way home, and that may have been the start of my hooky playing. But anyway, we moved up to Spokane, and in those days kindergarten was optional, and I never started it back up. So I just stayed home and started first grade the next year on time. Didn't seem to matter a whole lot. I went to elementary school in Spokane, junior high in Redmond over in the Seattle area, and then high school in West St. Paul, Minnesota. My father worked for the railroad, and every time he got a promotion, they'd transfer him somewhere new, it seemed like. And he started off as a telegraph operator for the Northern Pacific Railroad and ended up a vice president for Burlington Northern Railroad. So he had a long ways to work himself up the chain. And so we moved a lot. And I moved, let's see, we moved to Minnesota in March of my 9th grade year. And when we got off the train in St. Paul, it was a fresh snowstorm with about 10 inches of snow. And I guess that was a regular occurrence, learned that was a regular occurrence there. It was the week of the state high school hockey tournament. And so it always snowed then. So fresh out of high school, I went to the University of Minnesota for just 2 quarters. I had not a clue what I was going to do in college. And I didn't know what I wanted to do, except I'd been playing guitar while I was in high school. And when I started at the University of Minnesota, there was a little music store in Dinkytown, which is a little commercial area right near the Minneapolis campus. It's kind of like the Ave over in Seattle. And I was taking guitar lessons there, and I'd talk with the owner of that place a lot. And I thought he was just name dropping when he'd, mention these musicians that he knew and stuff like that. And later I read a newspaper article about him. He actually helped Bob Dylan on his Blood on the Tracks album. He put together a group of musicians from the Minneapolis area who played on that album. And so he wasn't name dropping at all. He knew those people. But anyway, I got more interested in music and dropped out after 2 quarters. And to tell the truth, my second quarter, I only took 1 class, or only finished 1 class, and that was English 102. I liked it because we got to read books. That's an addiction of mine that I don't talk about as one of my passions, but it certainly is. So I tried out music as a career. I moved out to Washington right after I dropped out of college, spent a month staying with my sister Kay, spent a summer staying with my sister Linda, both of whom are on here. And then I moved up to Bellingham for a couple of reasons. One was there was a guitar player up there I wanted to take lessons from. And the other was I didn't know anybody up there. And I'm shy, always have been, always will be. And I thought it would be good for me to move someplace I didn't know anyone. And so I went up there and did okay. I lived there for a couple of years. And then I read about another guitar teacher who had some classes in San Francisco. Moved down there, took lessons from him for, oh, I don't know, about 9 months, and a bunch of classes from him as well. And, but he got a job in a touring band. And so that was the main reason I'd gone to San Francisco, and I was missing Washington. So moved back up and started going to North Seattle Community College. And the reason I picked that school was because I don't know where I did it, probably at a public library, but I looked at the spring catalogs for every community college in the area, or at least all the ones I could find. And North Seattle had more music classes than any of the rest of the community colleges at the time. So I took as many as I could, and I got the whole first 2 years of music theory. I took choir, jazz choir, what else? They had a year-long jazz theory class that I really enjoyed. The third quarter of it, you got to write arrangements for little combos, and that was really fun. If I could have made a living at that, I would have loved it. And I was also working in the library, and I met this nice young woman there named Diane Cassis, and after I'd been there about a year, we got married. Let's see, I guess it would have been spring quarter. It was April 29th. I remember the date, fortunately. And along about that stretch, I was starting to realize that I wasn't going to make a living at music. There's a saying among musicians, don't give up your day job. And I'd never had a real day job before, so wasn't such a good idea. And I was starting to consider other things. And Diane wanted to study early childhood ed and wanted to go to Eastern over in Cheney. And I love Eastern Washington, so that was okay with me. And I was starting to kind of fish around for things to do. And I really, if I was going to go to college, I was actually thinking about majoring in English at the time because I love reading and writing and stuff like that. But I was taking some evening classes to explore other things, and the evening classes were in carpentry and cabinetry at Spokane Community College. And one night as I was going to be going to class, Diane asked me to pick up something for her at the store at the Fred Meyer in Spokane. She was taking an educational statistics class, and she needed a calculator. And so I bought a calculator. And this is the calculator that I bought, the TI-30. I still have it. When I dropped out of college, you could buy a calculator. A Hewlett-Packard calculator was one of the very first handhelds. And I think my brother Buzz paid around $400 for his. And at my $2.25 an hour janitor job, I wasn't going to get one of those. So I put up with doing things by hand or using a slide rule. But I bought this book, and it came, or this calculator, and it came with this nice instruction book called the Great International Math on Keys book. I haven't seen one in years, but I remember it because I stayed up all night going through it. And I decided that night I was going to go back to school and study more math. And so I did. And that was my stretch at Eastern Washington. When I got to where I was retaking calculus, I'd been taking it when I dropped out, but when I was redoing the calculus classes, I was kind of thinking I might want to teach high school math in a small town, but I thought if I took physics that I might be more employable. And after about 3 quarters in physics, I started thinking, this is more fun than math. And I felt like just taking math, I was learning the rules to the game, but in physics, I was getting to play the game. So that's why I ended up majoring in physics. When I retire, or now that that's coming, I'm toying with the idea of maybe finishing my math major if my old classes would still count. I don't know if they would or not, but I was only about 15 credits short of a bachelor's in math too. That would be kind of fun. I like math still, so that would be something. Okay, so I was, after Eastern, we moved to Minnesota. I thought it would be appropriate to go to graduate school at the school I dropped out of as a freshman. And so 5 years there, Diane and I had our 3 daughters in Minnesota. Sarah and Nicole were born in between my first and second quarters of graduate school. We refer to them as, or did for a while, as the Minnesota twins. And then Maria came along 3 years later. So all 3 of our daughters are Minnesotans by birth, at least. And when Sarah and Nicole were born, they were born in a hospital in St. Paul. And Diane was in the hospital for a couple days after that. And we had a dinner on Christmas Eve that they gave to new parents. And we're sitting there eating dinner, and they had an FM radio there, and I asked if I could change the channel because a Prairie Home Companion was on. And so I switched it over to a Prairie Home Companion, and from the room we were eating dinner in, we could actually see the theater where that show was being broadcast. Some of you may know what that is, but anyway, it's a public radio show, or was at least. So that was a pretty neat experience. The morning that Diane went into labor with Sarah and Nicole, it was 29 degrees below zero in St. Paul. And I think that was just about the coldest day the whole time we lived there. Okay, I've been at Big Bend since 1993, but I previously taught at those other schools that were mentioned. When I was teaching at Eastern Oregon State College, that was fresh out of grad school, I had taught every lab I possibly could in as a graduate student because I thought that might help me get a teaching job, and I think it did. But my 2 years there, actually the first day I was on contract, I think Jay Van Tassel and I met each other. Our offices were right across the hall from each other. And me being a brand new teacher, I was working 7 days a week most of the time, and Jay was too. He'd been teaching a while, but I think he's just kind of a workaholic. And I later found out I'm kind of a workaholic when it comes to teaching too. So, but Jay and I had a great time, and we loved the same kind of music and played a lot of music together. And so that was actually not a bad time there. Let's see. So that part was exhausting. What are my passions? Well, I'm going to get to a few of them. The important ones first. Diane, my daughters, my granddaughters, my brothers and sisters, and all my buddies. Those are very important. And then music. That's still important to me. And this is the earliest picture I could find of myself with a guitar. And this was actually at a wedding when Diane and I got married. I actually sang 3 songs at our wedding, and I started off with "The First Time Ever I Saw Your Face," which Roberta Flack made into a hit, but it was actually quite a bit older than that, and I learned it or played it more like the original version. So that was one of the songs anyway. Once I started majoring in physics, I kind of faded from playing music for quite a long time, and weren't such good years. Although in graduate school, actually, there were some friends I had there, and we'd get together and play music. Got a little bit more playing music when I moved here to Moses Lake. The fellow on the far left in this picture was Joe Rogers. Joe and I started playing music my very second summer here. We'd barely talked my first year here. He was over in the 1600 building, but I think he missed much of that year for some back issues he was having. But anyway, we started playing music in 1994, and gradually more people got added. The person playing the trombone here is Steve Close, and we started having, I can't remember if it was Tuesday night or Thursday night, that we would get together and play music. And had various people come in at different times for stretches of time. And then eventually we added the bass player over here on the right, Chuck Warren, and then the drummer back there, Stuart Hall, actually both of them together. I was honored to play with those guys. Chuck was in a rock group in the 60s that toured all over the place. And I thought Stuart was a really good drummer. And I never thought of myself as being in their league, but they were sure fun to play with. This is the white shirts and ties were when we were the Grant County Centennial Band back in 2009. And we didn't maintain the white shirts and ties forever. Before too long, we were wearing Hawaiian shirts and much more casual attire, but we had a great time playing together, and it was just a lot of fun. So music is one of the important things. Another thing for me is learning. I have never stopped learning, even the years I was out of school when I was actually studying music, taking guitar lessons, voice lessons, but I was also unconsciously learning some stuff. I was reading all the time. I know that during those 3 years out of school, I read every book by John Steinbeck. And then my sister Kay got me started on reading Dashiell Hammett books, The Continental Op. And from them, I went to other detective novels like Raymond Chandler and things like that. And if you read those old detective books, they had much broader vocabularies than you see in books nowadays. And when I came back to school, I didn't take any, well, I took a couple more English classes, but none that would have broadened my vocabulary. But when I took the GRE, I ended up acing the vocabulary part, and I had not aced the vocabulary part on the SAT when I took that. So it was just from all those books I read. And so that was some learning I did. But I've also taken some math classes while I've been here at Big Bend. I took linear algebra from Stephen Lane, and I learned more than I did the first time I took it as a student at Eastern. I took a networking class from Arthur Wanner and really enjoyed that. So I'm planning on keeping doing that. I took welding twice, and I'll probably have to take it a third time if I ever want to do anything practical with it. But there's that. Here's me in a class that I took. I think this one was back in 2012 or 13. And you might recognize those objects behind me there. Those are some of the radio telescopes for the Very Large Array in New Mexico. You might have seen those in movies before, like Contact. Jodie Foster was in that movie, and that was a part of the movie. Those telescopes are huge. They look like they're right next to each other, but the day that this picture was taken, they were actually about half a mile apart from each other. And so quite a distance. And then as part of that same tour, we got to go up in one of the bowls, and that was the brightest place I've ever been in my life. That white painted surface was really bright. It was painful almost, but lots of fun to spend 3 days learning about radio astronomy. And then my friend Jay and I, Jay the geologist, have taken a couple of summer geology classes. This was one on the geology of Lassen Peak and Crater Lake, and this is Lassen Peak, so we got to do that. By the way, if you ever plan a climb of Mount St. Helens, I don't know if Jay would still want to climb it, but take him along. It's like a geology course all the way up and down. You learn to identify all the rocks. Another class I've taken is another radio astronomy course. This one was in Green Bank, West Virginia. And I'd never been to West Virginia before, and I could almost believe the John Denver song as I'm driving along there. I didn't see any of the coal mining country, but the part that the radio observatory is in is just, well, heavenly, I guess. That's what John Denver thought, almost heavenly. So anyway, this was another 3-day course. And in this course, we got divided up into teams, and we actually got to use one of the smaller radio telescopes that was on the facility. And we could do observations of any object we wanted to, as long as it was above the horizon in West Virginia. You can do radio astronomy in broad daylight. So that's what we did. My team decided to look at the Andromeda Galaxy, which was up during the daytime. Some of the other groups got carried away and picked things that sounded really exciting, but then they found out that they were only up at night. And so they had to stay up most of the night doing their observations while we got to do ours in the day. And we discovered that the Andromeda Galaxy is rotating, and also that it's moving toward the Milky Way galaxy just from the hour or so of observations that we did. And of course, all that stuff was already known. There's going to be a collision in a few billion years between Andromeda and the Milky Way galaxy. So watch out. And then we also got to go up on the big telescope. And that's the one that's in this picture here. And by the time we got up to the dish to look at that, we were 280 feet off the ground. And it feels like a long way up when you can look down at what you're standing on and see right through it to the ground. So that was quite exciting. But the views were amazing from up there. So that was good. And then the last geology class that Jay and I took together was in the summer of 2019. And there's another one that we might be able to take down near that part of the country. But this one was on the geology of Mount Shasta and the Medicine Lake volcano, which is something you might not have heard of, but it's a volcano that's east of Mount Shasta a little bit, but not the snow-capped spectacular beauty. But there was some spectacular stuff associated with it. And one of our field trips went to this place where there was a large landslide that came off during one of the eruptions of Medicine Lake. I'm pretty sure it was Medicine Lake. And the landslide consisted mostly of obsidian. And this is a giant chunk of obsidian. I put a quarter sitting on it, and the quarter is right here. And so that gives you a sense of scale of that chunk of obsidian. And I tried to get the driver of our van to help me lift it into the van, but he wasn't having any of that. Can't say as I blame him. Okay, so other things I like. Teaching. I don't know of any profession that's better suited to me. I like to be able to keep learning and to try to share my love of learning with my students. And there's a great big world and universe out there, and there's nothing more rewarding to me than hearing a student say, cool, when they find something that sparks their interest. I've been able to take students on field trips a few times, and one that we did almost every year was to go down to LIGO, which is the Laser Interferometer Gravitational Wave Observatory. This is from the 2013 field trip, and you might recognize somebody over here. Maybe. It's hard to tell with a hairnet on probably, but anyway, that's Rafael Villalobos, and he got to go on that one. And we had a large group that year, but we got to go in what's usually the clean room that we wouldn't have access to because they were upgrading LIGO at that time. And from the first time I started going in there in about 2001 or so, I kept thinking, maybe next year. And so I kept listening to National Public Radio in the morning. It's just a habit anyway. But thinking someday I'm going to hear a story on there. And then finally in late 2015, some rumors started to circulate about a possible discovery at LIGO. And then a press conference was announced sometime early in 2016. And our time, it was about 7 a.m. in the morning. It was 10 o'clock Eastern time. But I recorded that whole press conference, and that's what my classes consisted of that day. And I told them all, okay, this is a famous day in history. Try to remember this date. And now I can't remember the date. But anyway, it was really special to have been going to that place so much and hearing so much about the promises, and then find out that they actually detected it. That was cool. So, and something that I really enjoy about my teaching now is the people that I work with. 6 years ago, I was the 5th oldest person in the building. And then in a span of about 2 years, all of a sudden, I'm the oldest by a long shot. Quite a few of my colleagues are the ages of my daughters or younger. But they're just a great bunch to work with. And the camaraderie and energy in our building and all the laughter and stuff and the food is just great. And if it weren't for all the mornings I'm up at 4 a.m. getting stuff ready, or all the Sundays I spent grading, I could teach forever. So, but I'm not going to. So, other passions. Making stuff. Holy smoke, isn't this guy ever going to get to astronomy? Pretty soon, pretty soon. Actually, this is some astronomy stuff. I've made all sorts of things, from raised beds to garden sheds to, those are the only two that'll rhyme, but that's okay. Anyway, this is a telescope that I made from plans out of a book that they have in the library called Build Your Own Telescope. And then other things I've made related to astronomy. This is a parallelogram mount binocular stand. And the parallelogram here is such that once you get the binoculars aimed at something, you can raise and lower them without changing what they're aimed at. And that's pretty neat. And plans I read about were just a single arm parallelogram mount. And I thought it was kind of wobbly. And so I designed, just sort of doubled the size of it and made a dual arm parallelogram mount. And this thing is really stable. I can swat that with my hand when I'm looking through the binoculars, and the vibration damps out almost instantly. And then I can combine my love of astronomy with my love of building things and my love of teaching, and have my students build binoculars. And actually, it was one of my students' idea to make these budget telescopes. He wanted to make a telescope one quarter, and I started poking around for plans and found these plans for a budget telescope made with PVC pipe and stuff like that. And I think I have helped to deliver about 75 telescope babies in my classes. And you might recognize the guy in the yellow shirt there. He was somebody I was really worried about for a long time, but now he's our dean of students. So that's Andre there. He was quite the cut up in class. Let's see. So making stuff. Finally, I'm going to get to astronomy. And I'm going to pause on the next slide, or the slide after the next one. This is some of what I do to enjoy astronomy. This is a picture of a star party. And that's one of the ways I've indulged in my love of astronomy. It also lets me indulge in my love of camping and just sitting in the sun reading a book sometimes. But the star parties are things where me and maybe a few hundred other star lovers get together in a dark place, then stay up most of the night looking at faint fuzzies through telescopes, binoculars, and whatever. And sometimes I just wander around at night looking through other people's telescopes. That's always fun. And usually at these things, people are happy to share their telescopes with you. There's a telescope in the background here that you can't see very well in this picture, but I had one of my neatest observing experiences ever looking through that telescope. It's bright yellow with green trim, and those of you who are farmers could probably guess what the nickname of it is. It's a landmark at the Washington star parties. Somebody will ask you, where's your scope set up? And you'll say, oh, I'm about, maybe 100 feet west of the John Deere. And got it. They know exactly where it is, and they'll know exactly what the John Deere is. And but it's a neat, good refracting telescope. And one year it was aimed at Jupiter when I was up there wandering around at night looking through the telescopes. And so I look at it, and one of Jupiter's moons was crossing its face, but you couldn't see the moon because it just kind of blended in with Jupiter. But you could see the shadow of the moon on Jupiter. And on Jupiter, there was this crisp black circle on there moving across the face of the planet very slowly. And that was one of the coolest things I've ever seen. And so that's the kind of thing you can do at these star parties. And they're all wrapped up in silver and stuff like that to protect them from the heat. So some of them are anyway. Okay, on to constellations. If you're in a bright room, you might want to dim the lights for this next little bit, because it's maybe hard to see the stars in all of these things. The first quarter I started teaching astronomy here, which I think was fall of 1995. The very first day or so, I had my students fill out a survey. One was what they preferred to be called and things like that. But I asked a question on there, what is it that you'd like to learn in this class? And nearly every student in the class said that they would like to learn to identify some stars and constellations. And so I started making that a part of the class. At the time, there were a few astronomy slides, and by slides, I mean these 35mm film things in cardboard folders or cardboard squares and a slide projector. And I didn't have a lot, but I had enough to kind of teach some. So I started taking photographs to get my own slides. And it was quite a learning process. I'd never done anything like that before, but it worked out okay. And eventually I found a type of film that I really liked the way it exposed, and I liked the color blend that I could get with the particular exposures I was using and the things I was taking pictures of. But I had a hard time finding anywhere to get it developed correctly. Here in Moses Lake, I took a roll to a large retail store on Alder. No, I guess it would be Stratford Road by that time. And I specifically requested not to have the pictures cut, to just get the roll wrapped up and given to me. They didn't listen to the directions. They cut all of the pictures in half, because since the constellations looked dark on the slides, they couldn't tell where the boundaries of the slides were, so they guessed. So that was one ruined roll of film. I took another roll to another place in town, and they developed the film okay and did give it to me uncut, but I used to develop slides. That was one of the odd jobs I had for a while. And they didn't agitate the slides during the developing, and so there was all these weird green tints in the slides and stuff like that. So I started going to professional places over in Seattle and found one. Seattle Filmworks was the name of it, and went there for years. But my last trip over there with film, 2005, I went to their store and there was a sign on the door saying closed, try Green Lake Photo. So I go to Green Lake Photo, which is another good place over there. They were closed. Finally, I got to Ballard Photo and had the roll developed, and they did a good job and everything. But the next time I was in Seattle, they weren't open anymore. So I realized it was time to go digital. And so with the digital camera, so started doing that. And that's what all the slides you'll see tonight are. I'm pretty sure they're all some that I've taken. And the one that you're looking at right now, some of you might recognize what it is, but I took this on a trip to Hawaii in 2011. I have an old friend from graduate school who went to work for NOAA after graduate school, and he's an atmospheric physicist. Now he's retired, but he was the lab director of the Mauna Loa Observatory, which is an atmospheric physics observatory. They measure things in the atmosphere, pollutants and various things like that there. And that's where they've been measuring atmospheric CO2 since about the 1940s or so. But we drove up to the laboratory, had dinner one night and drove up there. And it would have been nice. It was in the tropics and it was in July, but at over 11,000 feet, it can still get cold. And the wind was really blowing up there that night. It was freezing. I mostly brought warm enough clothes, but I was still freezing. It was cold, but I got some good pictures. And some of the pictures I got are things that we can't see all of here in Moses Lake. So the first picture I'll show you here is Sagittarius and Scorpius as well. These are two constellations of the ancient zodiac. Sagittarius is supposed to be an archer, although nobody I know calls it that. Everybody I know calls it the teapot, and that's what it looks like. There's a bunch of stuff down below the teapot part that are part of the constellation or part of the asterism as well. By the way, the word asterism means a recognizable pattern of stars. And so the teapot is an asterism. Sagittarius is the constellation. The constellation is actually an area of the sky, and the entire sky is divided up into 44 constellations. And the boundaries of those constellations are straight along lines of constant, well, it's right ascension and declination is what it's called in astronomy. On the Earth, we would call it latitude and longitude, but it's a way of measuring positions in the sky. And the constellations, because they're always along lines of constant right ascension or declination, they could look like Utah or Colorado do, but they don't, because they've got, for historical reasons, they've got all kinds of little jogs, but they're always straight lines. So that's what a constellation is in astronomy. Anyway, there's Sagittarius and Scorpius. The faint red that you see in these things, this is the NOAA observatory building here on the left side. And then over there are some small telescope observatories that are scattered around from smaller universities that don't have the money to buy into the telescopes on Mauna Kea. Okay, here's a longer time exposure picture of the same part of the sky. And there is Sagittarius there again. And I don't think I point up Scorpius. Maybe I do on this one. Anyway, it's over there. It's actually hard to find the constellations when you've got a time exposure that's this long, because it brings up so many stars that you can't see with the naked eye. And so it gets a little crowded. When we're looking in the direction of Sagittarius, we're looking toward the center of the Milky Way galaxy. And the Milky Way galaxy is that kind of milkiness you see behind those blue lines there. And it's been called that for ages and ages. And it just looks kind of milky. When Galileo started looking at the sky through a telescope, he realized that that milkiness was just an uncountable number of stars, and that's what was causing the milkiness, just too fine for our eyes to see. You also see black parts in there. Those are dust clouds that are in between us and the crowded stars at the center of the Milky Way galaxy. So they're just blocking the light. They're called absorption nebula is what those things are called. Okay, I think on this one, I point out the first of a deep sky object to look at. The M22, anytime you're looking at a star chart or anything and you see something that starts with the letter M and then it's just a number, it's referred to as a Messier object. And Charles Messier was a French astronomer who lived, his birth and death dates line up fairly close with Thomas Jefferson. So it was back around that time, born, I think, 1730 and died in 1817 or something like that. He was a comet hunter. Excuse me, I need to swallow some water here. Messier was a comet hunter, and there were a lot of comet hunters at that time. And he started making a list of things that were not comets. Now, in the time of Messier, most astronomers were using pretty small telescopes. He used a 4-inch telescope, 4-inch diameter telescope, and I would guess that the quality of eyepieces may not have been that good in that day. So it would have been easy to confuse a comet with some of these objects that he put on his list of things that were not comets. Nowadays, the Messier list the 110 objects that he found that were not comets is one of the favorite viewing lists for amateur astronomers. And so there's even a Messier marathon in April where it's possible in a single night to see all 110 objects on the list. But at the time, they were just things that weren't comets that he didn't want to have people wasting their time looking at. Here's Messier 22. It's something called a globular cluster, which is a spherical group of a very large number of stars. The stars that are in globular clusters tend to be very old stars, some of them like 12 billion years old. And so they're smaller stars a lot of times. And the globular clusters, there are at least 150 of them surrounding the Milky Way galaxy. And instead of being down in the flat disk of the galaxy where most of the stars are, they're surrounding it in kind of a spherical distribution around the thing. And so they're part of our galaxy, but in a way they're not of this galaxy. At least they're sort of standoffish in that sense. This particular one is about 10,600 light years away from us and has about 70,000 stars in it. So that's a lot. Okay, I think there's one more thing to show you here. Oh, a couple more things in Sagittarius to show you. The Triffid Nebula and the Lagoon Nebula. If you're under dark enough skies, you can see these with the naked eye, but they just look like faint fuzzies. But if you can get a good professional telescope, like say one with a 10-meter diameter mirror and take a time exposure picture, where'd they go? Oh, maybe I took those. I guess I put this slide in twice. Ignore that. Here's what those things look like. And the Triffid Nebula up there, and then the Lagoon Nebula to the left. And this is a very long time exposure picture that was done at a professional telescope. So that's why you see all those stars and things. Nebula is just a word for cloud. Nebulous is a word for something that's cloudy, like a cloudy argument or something like that. But the pink that you see here is from a cloud of hydrogen gas. Actually, when you look out in space, no matter what you see, you can say, okay, 3/4 of that is hydrogen and the other 1/4 is helium with trace amounts of everything else. And that's pretty much it. So when you look at something like this, the pink is actually from heating up hydrogen. And when you get hydrogen hot enough, it emits light. And the part that it emits in the visible spectrum is dominated by a red spectral line, a red color that's in there. And that's what makes these things look pink. The blue is a different effect. It's when light is passing through a cloud of gas and dust just shows up in trace amounts. But if you've got a dust cloud that's, say, 5 million light years on a side, it's pretty big and it can scatter a lot of light. And those blue clouds are blue for the very same reason that the sky is blue. The size of the particles in our atmosphere scatter blue light. And the size of the particles that are in the dust clouds in space will also scatter blue light if they're not heated up to where they're glowing. And so that's why you see that blue there. So anytime you see pictures like this, you can think pink, hydrogen, blue, scattered light from dust. So that's an easy way to identify that. All right, one more thing about Sagittarius. This is a picture that I took up at the Table Mountain Star Party one year, although it could have been the Oregon Star Party. I'm actually not positive, but it's something called Sagittarius A star. Now, something you might have noticed that those pictures that I took in Hawaii, Sagittarius was always far up off the horizon. When you come up to Oregon or Washington, Sagittarius barely comes above our southern horizon, moves across a little bit of sky, and then sets about 5 hours later. We just don't get to see it much here because we're so far north. But Sagittarius A star, I can't show you a picture of it. It's pretty much the center of the Milky Way galaxy, but visible light from it is blocked by all the clouds of gas and dust between us and it. But radio waves get through there just fine. And so radio astronomers can study this thing in great detail. And they discover that even if we could see it, if there weren't those intervening clouds of gas and dust, we still wouldn't see anything, because Sagittarius A star is a supermassive black hole. The radio astronomers can study the motion of stars and clouds of gas that are orbiting this thing, some of them traveling at up to 30% of the speed of light, which is really fast. And they can measure the mass of it. Anytime something is orbited, by studying the orbits of the things doing the orbiting, you can determine the mass of the orbited thing. And the thing being orbited is about 4 million times the mass of our sun. And it's in a region of space that is no larger than half the size of Earth's orbit, and probably much smaller than that, actually. So it's a pretty amazing thing. And that's the black hole at the center of our galaxy. So pretty neat. Let's move on to some other constellations real quick before I use up all my time. Okay, the Big Dipper, everybody's favorite. Now, the Big Dipper, all of those stars are in the constellation of Ursa Major. So the asterism is called the Big Dipper, but the constellation it belongs to is Ursa Major. So, and you can use it to find something else. So if the Big Dipper is all you know, remember the phrase arc to Arcturus, and follow the arc in the handle of the Big Dipper, and it will come to a bright star, and it's actually the brightest one it comes to soon. These may not do justice to it, but it's called Arcturus is the name of that star. And Arcturus is part of a constellation called Boötes, the herdsman. And I don't know, I don't see a herdsman there, but it looks like either a dented kite or a dented ice cream cone. And so that's something that's there. And then just to the left of Boötes is this little thing, Corona Borealis, which means, well, corona, crown, borealis, north. So this is the northern crown. I don't know if there's a southern crown or not. I haven't learned my southern constellations because I can't see them anyway, but it looks like a cereal bowl. So that's right next door there. So Ursa Major, Arcturus, that's the bottom of the dented ice cream cone, which is Boötes. And then Corona Borealis is right next door. And if you keep going to the left, yeah, this one I'll show you. There's Boötes again. You can't see Arcturus in this one. Right next door to Boötes is Corona Borealis. And then next door to that is Hercules. And a lot of times with Hercules, you won't see this part of it. In fact, when I learned it, I just learned this part of it up here, which looks like a bow tie. If you look, rotate your head about 105 degrees, is it, Sarah? All right. Anyway, the right amount for a water molecule, and you get that. And then there's a couple star names you could learn in Hercules if you, oh, one more constellation up there, Lyra, the heart. So I can name some more stars in here, and I think we're nearly done with stuff. So Vega is up there. That was the star that Jodie Foster visited in Contact. I forget her character's name, but that's okay. And down here in Hercules, Corniferous is that star. And Rosal Gethi is that star. An awful lot of the star names you see were Arabic. When the Roman Empire fell and pretty much European civilization fell with it, a lot of the knowledge that had been acquired by the Greeks ended up in the hands of the Arab astronomers, and they would rename the stars to their own fancies and things like that. The constellation names seem to keep the Greek names, but a lot of the star names got renamed by Arabs. And I can never remember what all the stars' names are, but I think Rosal Gethi means the head of the kneeler. Another name for Hercules is the kneeler, because if you fill in some more dots on the asterism, you get, looks like a person kneeling. Okay. And, oh, a deep sky object in Hercules, and this may just about do it. M13, so it's another Messier object, and another globular cluster. This one has about 300,000 stars in it, so a lot bigger than that other one, the M22 that we looked at. This one's 25,000 light years away from us, and possibly visible to the naked eye from a very dark place. I haven't ever really concentrated on trying to see it myself, but may be visible. I might not be able to with my eyes anyway, actually, but that's okay. Oh, there's one more group. Okay, Cygnus. These are summertime constellations. Oh, good summertime things to learn. So Cygnus, there's Lyra down there. And okay, the name of this one, I've heard it pronounced Aquila, Aquila, Aquila. It's supposed to be an eagle. So I think in Spanish, is it Aquila? I'm not sure. But anyway, it's supposed to be an eagle. And I don't know how they would pronounce it in Latin anyway. So they would have had it. And then a couple little tiny constellations. This is Sagitta, the arrow. And over here to the left of it is Delphinus, the dolphin. And if you rotate your head about 120 degrees to the right, you can kind of imagine a dolphin shape with that one. So a little bit challenging. But if you take the 3 brightest stars, I need to change a text box size there. The brightest star in Cygnus, which is Deneb, oops, got some more, Solder, Alberio. If you can find this in the sky, check out Alberio through a telescope. It's got a little surprise for you. So there's that. Okay, Lyra, Vega, Altair, Aquila, or Aquila, or whatever it's supposed to be. Okay, this time the final 3, Deneb, Vega, and Altair there. And those 3 stars together form what we call the summer triangle. And on a summer evening, if you go out and sit at a picnic table or on something like that and kind of look straight up practically, this will be one of the first things that pops out of the twilight. And so you can enjoy that. Okay. Think we're done, if this would let me. I'm going to escape here and go to the end, if I could escape. I wanted to show just one thing. This is something called the Ring Nebula, and this is a Hubble Space Telescope picture, so you will not see this. But if you look through a decent amateur telescope, you can see a little smoky donut where this thing happens to be. And it's called a Planetary Nebula. It's a misnomer. They were called planetary because the first ones that were discovered looked a little bit like Uranus did through the small telescopes of the time. So just kind of a fuzzy, round thing. And but it turns out to be that stars, like the sun, late in their lives, the sun will eventually swell up and become a red giant. And then it will gently puff away its outer layers at some point. And when those outer layers get puffed away, left behind will be the core of the sun, which is going to be very hot. And it will heat up those outer layers that it puffed away and make them fluoresce. And so this is the dying spasm of a star that's about the same size as that of the sun. I don't know if either of those 2 little white dots that you see in here are part of the old core or not. They could just be background stars. But this is a nebula, a cloud of the outer layers of the star that were puffed off, that is glowing in the visible part of the spectrum from that really hot core that's lighting it up there. So that's one of the neat things you can see in astronomy. And you can see this through an inexpensive telescope. It just won't be in color. You'll see a faint gray donut. Okay, the last slide. Tom Willingham asked a question that I wanted to address anyway. He said, is there a dark side of the moon? And yes, there is, but it changes. The dark side of the moon is whatever side of the moon is facing away from the sun at any given time. And the moon turns on its axis just like the Earth does, except the moon takes 27.3 days to turn on its axis. And that's exactly how long it takes to orbit the Earth. And so it always keeps the same face toward the Earth. But if you were on the moon, you would experience sunrises and sunsets just like you could on the Earth, except it has no atmosphere to scatter the light and make the sunset look red. But there is a dark side of the moon. Maybe what's a better question, is there a far side of the moon? And yes, there is. It's the side facing away from us that always faces away from us. But the Chinese just landed put a lander there, and I think it had a rover, I'm not sure. So, well, not just, it's been a little while now. But okay, I am finally done. Sorry, that took longer than I thought. I would have cut out more if I'd actually run through it time-wise. Did I lose my Zoom meeting or not?
Oh no, that was fascinating, and I love every minute that you gave us. I hope that the additions that I gave in the chat, I provide a lot of links that related to points that Jim made. That was excellent, very engaging and informative, and your passion is so clear.
Okay.
And so, thank you. And now I'm going to ask the few panelists we have in our Passion Project Showcase Committee to unmute yourselves, since I muted you all. And then we're going to go through and have a little bit of a discussion with Jim. And Tiffany is still keeping track of the questions that you have posed. So we've got some great questions from our audience members that we'll be addressing as soon as we finish our little Q&A session with him. So please keep posting there. And we're going to start first with a question from Rhonda, and then we will go to Melinda. So Rhonda, please.
Thank you. Thank you. And thank you so much, Jim. That was so amazing. You're going to give me a love for Washington yet. So my first question is, the top 3 states for UFO, unidentified flying object sightings in 2020, California, Florida, and then Washington. Washington had 222 UFO sightings last year. In the report by the National UFO Reporting Center, 27 sightings happened in Moses Lake over the past decade, one of which was near the Big Bend Community College campus. What do you think these students actually observed over the dorms?
Okay, well, I read about that one that was on your question, and I'm almost certain I know what they saw. Let's see, I can share something with you.
Yeah.
Let's see, I think, share screen. We'll just go to Stellarium here. And this is an online web app of some astronomy software. And the date was April 13th, if I remember right. So I can set the date to, I don't remember what year it was, but it doesn't matter. Every April 13th, we're going to see the same batch of stars. So I'll go to the 13th. And I think they were probably looking toward the southwest. And every spring on April 13th, what's very low in the southwestern horizon is the star Sirius. And when a star is close to the horizon and you look at it, if it's high above your head, you're looking through about 20 miles to get through about 99% of the atmosphere. But when it's close to the horizon, you're looking at many times that distance. And so the light from Sirius has to travel through a whole bunch of our atmosphere in order for our eyes to see it. And when it does, the atmosphere, thermal currents in it and dust and just all kinds of stuff will stir up the light pretty good. When we've been out stargazing, sometimes we'll be out there when the moon rises, and it's always fun to aim the telescope over toward where the moon is rising. And you don't see this with the naked eye so much, but when the moon's coming up, it looks like it's coming up through a pot of soup, because the atmosphere is just mucking up the image so much. And I'd be willing to bet that's what those guys were looking at was Sirius, because I've seen, oh, Capella is one that's in September. If you look north, it's really low to the horizon, and it'll look like it's changing colors on you. You'll see first it's white, then it's blue, then it looks like it's red. So it's just the Earth's atmosphere that's fouling things up. They also mentioned that they were looking through binoculars at it. I don't mean to disparage them, but most people don't know how to focus their binoculars, and you have to do them individual barrel by individual barrel. And if you don't get them together, when you're looking at something like Sirius, one eye might be sharp and the other one would be a fuzzy round ball. And now you've got a fuzzy round ball that's changing colors, which is exactly what they described. So I suspect that's what they saw. And I think probably nearly all UFO observations or reportings are just natural phenomena that people don't understand. So, although I just read something in the Washington Post about Navy pilots seeing unusual things, and I'd like to hear more about that. But I'm still a big skeptic. Don't mean to throw water on your thing, but usually, I don't know, the universe is amazing enough without having to invent things like that. Have you ever read Carl Sagan anything? He wrote a book called The Demon Haunted World. And in that, he was talking about how 300 or 400 years ago, there were all these reports of witches and devilish creatures that were plaguing people and all sorts of stuff like that. Those have just kind of vanished. Johannes Kepler actually had to spend quite a bit of time defending his own mother from a charge of witchcraft. And that's just the way the world was at that time, the way people were interacting. Now, do those things, are they still around? Probably not. Nowadays, people come up with UFOs instead of witches.
Thank you, Dr. Hamm.
Oh, sure. By the way, you don't have to call me Dr. Hamm. I got out of the habit of that back when Jay and I were teaching at Eastern Oregon, that Jay always said, oh, call me Jay. And I would tell my students, you don't have to call me Dr. Hamm unless you're worried about your grade. And then it would be better to say, oh, most esteemed one. And that would work better. So.
Wow, that's just so interesting. The more you share, the more I realize how much more there is to learn about things. So my question is off of a quote that I recently read.
Oh, that's right, the toughie.
The quote's from Dr. Carl Rogers, and he said that a person is a fluid process, not a fixed and static entity, a flowing river of change, not a block of solid material, a continually changing constellation of potentialities, not a fixed quantity of traits. So the use of the word constellation in the quote made me think of your passion for the stars. And do you see similarities between the night sky and Rogers' quote about people?
I think I do. When a constellation is actually an area of the sky, okay? And when we look at it, a lot of times, all we see is the bright stars in the asterism, whatever constellation that happens to be. But there's more to it than that. Everything within those boundaries is part of that constellation. And a lot of those things are not stars, they're globular clusters or clouds of gas and dust. And we're not seeing the three-dimensionality of it. So we can't even see stars farther. I think the most distant star that you can see with the naked eye is estimated to be about 4,000 light years away. Okay, the Milky Way by itself is 100,000 light years across. The Andromeda Galaxy, which you can actually see with the naked eye, but it's because it's a group of a whole bunch of stars is 2.5 million light years away. And so there's depth to all of these constellations. Every one of them has other galaxies in it, and they're not static. Okay, the stars are changing and they're moving around. If you waited around for 100,000 years, the Big Dipper would not be recognizable because all of the stars in that asterism are moving through space at various rates, and it's not going to be a recognizable shape after that time. So just the stars themselves are moving, and they go through changes. One of the questions Tom asked was, is it true that some of the stars we look at don't even exist anymore? And I would say probably not for the naked eye stars, because since we can only see out to about 4,000 light years, we only see ages from within 4,000 years. And that's a pretty short time compared to the lifetime of even the shortest lived stars. The shortest lived stars have lifetimes of maybe down around 1 million years. 10 million might be more common, and 4,000 compared to that just isn't very much. But if you start using optical aid, pick up a pair of binoculars, you can see a lot farther away with fainter stars with that. Pick up a telescope and you can see much fainter things. Get a 100-inch telescope like Hubble was using on Mount Wilson, and you can pick out individual stars in the Andromeda Galaxy. Now, that's 2.5 million light years away. That means the light has taken 2.5 million years to get here, and probably some of those bright stars that he saw are dead. They're completely gone by just in the intervening 2.5 million years since they emitted that light and it finally got here. A neat activity that I'll have my class do when we taught in a regular room was to have people standing in a group over on one side of the room and pretending that they're stars in a galaxy that's 100 million light years away. And there are lots of them that are. And then one of the people in the group is to represent the first light from a star that has a 50 million year lifetime. And they're supposed to walk toward the other side of the room, which is where Earth is going to be. And they get halfway there, and they've been traveling for 50 million years. And now another person leaves who's going to represent light that came out of the supernova explosion of that star at the end of its life. So now you've got these two people walking across the room. It'll still take them 50 million years to reach Earth. And it's the first light and the last light ever from that star in that constellation. And wow. So things are changing. And yeah, people are like constellations too, or constellations are like people. So that's okay, amazing. I got going on that one.
That's amazing. Thank you.
Yeah. That's super awesome. And I'm going to take the next question, and then Sarah and Tiffany will follow up here. So my question is, what do you find is the hardest thing for students to understand about astronomy?
I think it's probably something that my science colleagues share. Lindsay, have any trouble with students understanding the density idea? It's hard to think logically about mathematical relations. And a lot of the mathematical relations we can use in astronomy are things that are, say, an inverse function. And sounds scary, but all it means is if the star moves farther away, the gravitational force it exerts gets weaker. Or there's another one that it's something related to the wavelength at which a glowing object gives off the most light. Turns out it's inversely proportional to the temperature. So the hotter the object is, the shorter the wavelength of the most intense radiation coming off of the object. And those ideas are kind of weird and kind of hard to wrap your head around, but you can explain so much with them. And that's one of the things. And it's partly thinking logically and also reasoning mathematically. And it doesn't have to be complicated math. It's just reasoning with it. You know, if it gets weaker this way, what's going to happen if you go twice as far away, say,
Mhm.
stuff like that.
So is that because of how hot it is, if I can ask? Like so it's the heat that makes it less?
No, it's
Okay.
it's actually the hotter the object, the shorter the wavelength of it's actually the hotter the object, the higher the frequency of the light that it gives off
Okay.
most of.
Okay.
But we
Okay.
tend to observe wavelengths instead. So,
Okay.
or measure
Great.
the light in wavelengths. But if you know the wavelength, you can get the frequency and vice versa. So.
Awesome. Thank you. I'm not sure I fully understood that, but I am going to think about it and try to understand it more. Thank you. I really appreciate that.
Was there a favorite constellation? Or
Well, we're going to go on to Sarah.
Okay.
Right. So I just know that Dennis Knapp is going to love my question. Sorry, Melinda, I think we have feedback. Are you muted?
No, I
Yeah.
got you now. Yeah, I got you.
Okay, we're good. All right. So Dennis, you're going to love this question. I just know it.
Uh-oh.
Many of the constellations have Greek mythology attached to them. What is the most interesting story about a constellation from the Greek mythology perspective?
Okay, well, when we were talking about this the other day, I'd completely forgotten about something that I'd done when I was a student at Eastern. And I'd mentioned this one story, and then I got to thinking about it, and at Eastern, when I was there, they had a class called Planetarium Operations, and they have a planetarium in the science building, and you could learn to do planetarium shows in there. And so I took that class. I thought it was a lot of fun. And as a project for the class, you had to give a presentation. And so the presentation I gave was on the story of Cepheus the king, and Cassiopeia the queen, and Andromeda the daughter, and Cetus the sea monster, and let's see, Perseus the hero, I guess. And the story was that Cassiopeia was very vain, and she was bragging about how she was more beautiful than somebody or other, maybe the sea nymphs. And the sea nymphs heard her and went and told whatever god that she disparaged by saying she was more beautiful than her, goddess, I guess. And so maybe it was Poseidon. Anyway, Poseidon sent the sea monster to attack the coast of either Ethiopia or Jaffa. The stories vary as to where it was. And so this sea monster is attacking, and Cepheus and whatever her name, Cassiopeia, decide they'll sacrifice their daughter Andromeda to the sea monster, and that will appease Poseidon, and then they won't be attacked anymore. So they chain her to a rock, and Perseus is flying back from killing the Medusa, and he's got the Gorgon's head in his hand, and anyway, he kills the monster somehow, and then goes and talks to Andromeda's parents and extorts a kingdom from them and their daughter's hand in marriage. And so he just comes out ahead on everything. And some of the versions of the story have him showing the Gorgon's head to the person that Andromeda had been intending to marry, and also showing it to his mother-in-law Cassiopeia at the wedding and turning them to stone too. So man, you gotta love these Greek mythology things, are just real tearjerkers. So that's probably my favorite one.
Thank you so much. And thank you for all you've done for our students and for Big Bend. You're amazing. We really appreciate you.
Oh, when I did the story at Eastern, I put music to it. And the sea monster, I picked some music from Rite of Spring, some really scary monster music. And then for Perseus, I used one of the pieces from the Nutcracker, the one that goes whatever it is, I forget the name. Pat Patterson would be ashamed of me, I think. Okay.
So I've got the last question just from the panel. And then there's a couple of questions that popped up in the chat that we'll relay to you. My question though goes back to your initial slide on your long list of passions. And you specifically talked about how music was an early passion. You know, you took all those classes and then realized you needed to pivot. And so was it difficult to shift focus then and pursue a totally different career? And you know, what would your advice be for those in a similar position who are struggling with juggling passions and finding which one they want to really pursue?
Well, I wish everybody could do what I did. And you know, it was during the 1970s. I lived in San Francisco at a minimum wage job, working 20 hours a week, and I could afford to live and take music lessons and buy all the records I needed, or all the records I wanted to, and stuff like that. And you just can't do stuff like that anymore. And for the years that I was out of school and then going back to North Seattle, I was able to support myself on 20 hours a week. And I wouldn't trade that time for anything. I had very little experience in anything when I got out of high school and started college the first time. And just having a bunch of crummy jobs, washing dishes in a restaurant, being a janitor, spending one summer delivering free samples of Era laundry detergent, stuff like that, it kind of makes you value education a little more, I think. And also it, you know, I knew stuff I didn't want to do. Having worked in a few restaurant kitchens, I didn't think that was the life for me. I mean, it was okay, you got fed, but just wasn't good. So I wish people could just go out and experience things. And maybe if we start up something like a civilian conservation corps, I'm starting to read about things like that, or some kind of national service projects, I would encourage people to do stuff like that for a few years out of high school and just experience more of the world and learn some stuff. Because that's what I kind of had to do, was just get out and experience a few things. And I knew what I didn't want to do. And then I ended up just taking off on something that I love, which is math, and then going to physics, which I also love. And I can still play music. I just can't give up my day job for it. But in, let's see, 32 days, I think, my grades will be turned in. My office might be cleaned up, and I should have more time to practice guitar and banjo and other stuff. So there's time. I'm thinking of seeing how big a dent I can make in the 10,000 hour rule. So I don't know if anybody's read about that or not. I figure I've probably got a couple thousand in already on guitar, so we'll see how it goes.
Thanks, that was great. So there were just a couple of questions that came in through the chat box, so I'll kind of field those to you. The first one, really easy. What is your favorite genre of music? And I'm sure whether that's to play and or listen to.
I would probably say Americana, and that's a sort of new category that's fairly broad, but it includes, for me, kind of alt country. People are on the fringes of country music, not the commercial stuff. Folk music, blues, bluegrass, mixtures of all of those. And that's kind of what our band did when I was happiest with what we were playing at the time anyway. Not the pirate band. That's in a category by itself. But that's the style. But I like a lot of other music. I mean, I like, geez, I like listening to Grateful Dead, Allman Brothers, Beatles, Rolling Stones, all kinds of classic rock like that. And I like classical music. When I started majoring in physics, I was reaching the point on piano where I thought, if I keep playing about another 5 years, I think I could start working on Beethoven piano sonatas, and never got there. And now I'd probably have to start over again. But I love that kind of music too. I've got pretty wide interest when it comes to music. I got spoiled when I was in high school, living in St. Paul. the St. Paul Chamber Orchestra gave concerts, and if you got there the day of the show and they had tickets left, you could get in for $2. And so I went to a lot of St. Paul Chamber Orchestra concerts just for that. And I had a friend who was, he was first chair clarinetist in the Minnesota Youth Orchestra. And being in that, he could serve as an usher at the Minneapolis Orchestra concerts. And he'd just invite me along to be an usher too. So I'd get to see them play as well. So those were fine as well. And then other times I'd go and see Neil Young at the Metropolitan Sports Center. So
so another question that came in was any plans, now that you have time with retiring, to check out the Southern Hemisphere sky?
oh yeah. I didn't mention this, but I go to these star parties. I've been to star parties in Oregon, Washington, a couple in Idaho, and one in Montana one year. But I want to go to a star party in Australia. They have them, and sometimes their seasons are off of ours, although Australia is just about in the tropics, so their seasons aren't so extreme. So you could go there in the winter and it's not going to be that bad. And I want to go to a star party in Australia. I also want to go to Chile and tour the, somehow get a tour of some of the Chilean observatories, because those are the best telescopes in the world right now. And don't know how I'd wrangle that. I may have to go on a tour with one of the astronomy magazines or something to have them take care of the logistics of that. And that won't be cheap. No, that would be kind of pricey, their tours are. But there are some where you go on the tour and they'll have like 3 of the nights during the 10 days you're there set aside just for stargazing, and they provide you with a telescope. So I could do that. That'd be just fine.
Excuse me. So another question was, you talked a lot about, or you showed us a few things to look for in the sky, but what is your favorite thing to look for?
One of my very favorite things, I like binocular observing, and I don't know if it's just because of my vision or not, but I really like getting a pair of binoculars adjusted, focused for my eyes. You have to focus one for the left eye and the other one for the right eye, and then you'll be in focus. And I like things that are binocular objects. And one of my favorite things to look at is the Pleiades star cluster, which is in Taurus. And actually by August, if you stay up late enough, you can see it in the morning post-midnight sky, I guess. And at the star parties, it's not unusual to stay up until it starts getting light. So that's a favorite thing, is the Pleiades star cluster. And then the constellation of Perseus, I just like looking at it through binoculars because it's very crowded with lots of bright star fields. And you just start exploring those things and you see some interesting shapes that are never going to be famous asterisms because you need binoculars to see them. But that's something else that I like. And through a telescope, in Perseus, there's a double cluster. That's one of my favorites. It's in between Perseus and Cassiopeia. And it's, if you have a low power eyepiece on your telescope, you can see these 2 clusters of stars in one field of view. And that's kind of a neat thing too. So those would probably be my favorite things. And those are fall time constellations, or late night on an August evening is when you can see those best.
Thanks. So we just had one more question that was left in the chat. Do you plan to continue having public stargazing nights after your retirement? I'm assuming they mean in this area.
I could. Depends on whether or not they need me. If they need me to teach astronomy, I'd still be willing to keep my hand in and do those things. I really like the public stargazing events. And we did one in the summer a few summers ago that could have been good. There were a lot of planets visible that night, but it was the smokiest night of a stretch of really bad smoky days, and you just couldn't see anything. The stars or the planets that were out that night looked really bizarre through all the smoke we were seeing them through. So, but I'd like to do that again. And then we could have, you know, a stargazing night in the fall, and we could have a star of the season constellation show first or something like that. So I'd like to. And I've got a lot of friends who would be happy to bring their telescopes too. So.
Well, I think this group at least is all in agreement that we will all attend if we do one. Thank you so much for answering those questions. I'm going to turn it back over to Allison now.
Okay, well, it's fun, and I'm sorry I got so long-winded.
Oh,
Give a guy a
please.
microphone, he won't shut up.
Please, this is what we wanted. And while we don't always think of the showcase as a way to celebrate people who are leaving, that's what we're really glad we got a chance to do here with you, so that we could squeeze you in and make this showcase what it should be, which is just the awesome people we have here at Big Bend sharing their passions, and those passions extend way beyond the classroom. And I think that we're all a little better and a little more interesting for having listened to your presentation, Jim. This has been fascinating for me because I never took astronomy in my undergrad because I thought it was going to be too hard. I have to admit, it was a fixed mindset, and I was afraid. And now I'm thinking that if you do end up continuing to teach for us here, I might have to take one of your astronomy classes, assuming I have the math to even get there. So I teach English, so I'm going to put that out there.
Lindsay could help you. She wants to take it too.
Oh, we could be partners together. Yes, I would love that. Yeah, so this was just fantastic, Jim, and you are such a special part of our faculty, and I don't think of losing you. I think of you gaining the time that you deserve to just explore and continue to develop your passions. But I don't want to end this without giving anybody a chance to ask any final questions that you have. And it doesn't matter what that question is. If you want to know it, now is the time to ask it. So I'll just give you a minute there to get yourself ready to ask. You can also put it in the chat if you would prefer. So are there any
Piper or Gabriella have a question? Let's see. I'm not sure they actually got on. Actually, they're probably in bed. It's bedtime in Boise.
Oh, we have, what is your greatest moment as a teacher? Thank you, Aaron.
Actually, I've had a few. Several years ago, first we had a student in Science 101, and he took that, and then the next year he took engineering physics. And talking to him, he had dropped out of high school, I think in 10th grade, something like that, after his father died. He needed to go to work to help support the family, which is kind of a parallel of my father's life. He had to drop out of high school to help support his family. This was during the Depression, but this guy was coming back to school. And when he left Big Bend, he was chosen as the outstanding mathematics student that year. And then he went on to the University of Washington, and I think he got a bachelor's in aeronautical engineering. I'm not sure where he went after that, but that was kind of cool. And people like that, I think that's why we have community colleges. But he sent a message back one time. There was something where we used to do this thing where faculty would go out to universities and talk to students who'd been here, and they talked to him, and he said, man, I was so glad for what I did for Mr. Hamm and Mr. Lane. I hated it when I was having to do it, but I got here and I was so far ahead of my classmates. And in one particular thing, it was about the lab reports that I had him do. And that felt pretty good. And I knew they hated it while they were getting it, but they learned a lot from it. So that felt pretty good. And I had, I think the second year I was teaching, I had a student down at Oregon who was hounding me to ask me questions all the time. And at the first of the year, they weren't very bright questions, but he kept asking questions and working at stuff and working at stuff. And by the end of the year, when we got to electricity and magnetism, he was asking hard questions because he knew all the easy ones. And seeing somebody go through that kind of growth is really moving, I think. So.
And I think that's one of the best things of our job as faculty members, just getting a chance to see that happen.
Mm-hmm.
Yeah, great. We did have a question about when your retirement party is. I'm sure there's going to be one. I don't know if we have any date or time picked out, but I can probably
I'm going to party all summer.
we'll have some kind of Zoom event, particularly because we are still dealing with the obstacles of the pandemic. And so I think we will keep you apprised of that.
Okay.
So please, yeah, we will spread that information. Sarah Hamm Rush, I'm assuming as a family member, you will definitely get that information too. Yeah.
Let's see. Sarah Hamm Rush is a daughter in Bremerton. Is Zola still up or not?
No, but she interrupted your talk and I had to leave for about 15 minutes while she was crying.
Zola is, let's see, almost 6 months old, isn't she?
Yeah, next week.
Okay.
Zola. Oh, is Zola? Does Zola happen to be named after Emile Zola, the an incredible naturalist writer, or was it just a great name?
No, she's not named after anyone in particular, but that's one of the only Zolas that we know of, actually. We just liked that it was unique, and the name means earth, which we thought was beautiful.
Beautiful. Yeah. Well, and that doesn't surprise me. Not far from the what's that? The tree. The acorn doesn't fall far from the tree. Is that the beauty? Seeing the beauty.
That's Sarah, who's she was a lone something or other officer at the Gates Foundation. What's your job title now, Sarah?
I'm a senior program officer. I make grants to organizations addressing HIV.
Okay.
Oh, that's awesome. Yeah. Wonderful. Are there any final questions that we can ask Jim?
Well, I'm ready for a break.
Well, do you have any final words you would like us to leave with, or can we just leave you with a round of wonderful reaction applause?
Well, thank you. Keep learning. Okay. And keep enjoying life. So, yeah.
Thank you so much, Jim. Yeah, and thank you for all of you. Yeah, we're going to post this recording. If I am correct, on the Passion Project Showcase page that I provided a link for earlier, let me provide one more link to that. So this is also the page where you can find a copy. I'm going to share my screen really quickly of Jim, the ebook created by Jim and designed and brought to life by Rhonda Kitchens, the co-chair of this committee. And it is there for all of you to access at any time that you want. And please feel free to share with everyone. And thank you again for joining us as we celebrate Jim and his almost 30 years of supporting our students and bringing people's star knowledge to life and making it matter. And we really appreciate all of you. Thank you and have a great night.
Nighty night.
Good night.